Hi everyone, my name is Teresa, and this is my project called Reenactment of the Past for my subject physics. First of all, I want to introduce my project by talking about the big question, which is why do visionary leaders adapt? Visionary leaders adapt to be able to analyze difference from the present and the past. In this project, we adapted ourselves to learn the difference from the past and present with the laws of Newton and physics. Our focus question is, how can humans analyze transformation based on physics, concepts, and law in day-to-day activities? Our first outcome is able to develop forward-thinking designs based on the understanding of Newton's law of motion. Our second outcome is that we are able to analyze daily life problems based on the principle of work, energy, and power. Our mission for this project is first, to analyze pictures from the present and the past, and to analyze the laws of Newton applied, as well as calculations. First of all, this is a picture of me when I was a toddler, accompanied by my brother and my mother, who's holding me up to keep me standing straight. As you can see, the force of gravity and the lack of knowing how to walk is pushing me downwards, but the force of my mom's arms and my will to stay up straight keeps me standing. I'm leaning a little slightly toward my left, but the friction and the weight of my mom's arms keeps me standing straight. And now I'm going to be talking about Newton's first law of motion. According to Newton's first law of motion, an object remains in the same state of motion unless a resultant force acts on it. If the resultant force on an object is zero, this means that the stationary object stays stationary, or a moving object continues to move at the same velocity, which is at the same speed and in the same direction. And now we're gonna look at the mechanical energy in this picture. First of all, let's lay out the facts. At this moment, let's assume I was 5 kilograms. The gravity was 10 meters per second square, and my height was around 50 centimeters, and the velocity is 0 meters per second. First of all, the potential energy is mass times height times gravity, so it's 5 times 0.5 times 10, so the potential energy is 25. Next, the kinetic energy, mass times velocity squared over 2, and the resulting number is 0 joules. And now for the mechanical energy, it's just the potential energy plus the kinetic energy, 25 plus 0, which is 25. Newton's law of universal gravitation is usually stated as that every particle attracts every other particle in the universe with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The law of gravitation is a law stating that any two masses attract each other with a force equal to a constant, which is called the gravitational constant, multiplied by the product of the two masses and divided by the square of the distance between them. Gravity causes attraction between all objects. Every mass attracts every other mass. And here, I would like to add something about Newton's third law of motion. According to Newton's third law of motion, whenever two objects interact, they exert equal and opposite forces on each other. This is often worded as, a reaction has an equal and opposite reaction, which is correlated to the picture that I have prepared 2 slides ago and the calculations that I have done. And to conclude this video, I want to answer the focus question first. Humans are able to analyze transformations from the past and present by learning scientific laws and rules. By learning them, we are able to learn more about ourselves and the nature of science. Newton's laws of motions are important because they are the foundation of classical mechanics, one of the main branches of physics. Mechanics is the study of how objects move or not move when forces act upon them, a lesson proving immovable objects and unstable forces are one and the same. That is all for the video that I've prepared today. I hope that you have enjoyed it and learned something new. Thank you.